What is the value of total charge flowing through the coil during 0.05 seconds? Whereas the diameter of a long solenoid is given in the question. And at the center of solenoid, a coil of 100 turns and radius of 0.01 meter is placed with its axis coinciding with the solenoid axis. The current in the solenoid reduces at constant rate to 4 ampere in 0.05 seconds, and the resistance becomes 10 pi square ohm. So the question is, what will be the value of total charge on that time? It's known that the total charge can be calculated using a formula E divided by R times del T, whereas E is representing the value of induced EMF in a solenoid, which can be written as minus N times d pi over dt. So here we are only going to calculate the magnitude. So we can take modulus of E is equal minus N dot d pi over dt, which will be equal to N d pi over dt. It's known that pi is representing the flux, which will be equal to B. So here we can write N times d over dt of B. So here B is representing the magnetic field value, which will be equal to mu naught Ni, whereas N is representing number of turns in a solenoid, whereas capital N is representing number of turns in a coil. So here we can write E will be equal to N divided by dt of d of B value mu naught Ni times A. So here our work is to finding the value of charge. So Q can be written as N times mu naught Ni A divided by dt times del T of R. When we are simplifying this, we will get the value of Q as N mu naught N I times A divided by R. As I said already, N, capital N is representing number of turns in a coil, which is given as 100. Whereas small n is representing number of turns in a solenoid, which is given as 2 times 10 to the power 4 turns per meter. Whereas mu naught is representing the permeability of free space, which is equal 4 pi times 10 to the power negative 7 Tesla meter per ampere, whereas I is representing the value of change in a current, which is given as changing from 0 to 4 ampere. So here I will be equal to 4 ampere, whereas R in the equation is representing resistance, which is given as 10 pi square ohm in the question. Now we can apply all the values in the formula, but there is no detail about the area. It's given in the question. The material is having a diameter of 0.1. So we can calculate the area pi r square, which will be equal to pi times 0.01 the whole square, because here there is a detail about the diameter. When we are dividing this by 2, it will be equal to 0.01. This is our radius. So now we have a value of area N mu naught I and R. When we are applying everything and when we are simplifying, we will get the answer of 32 pi microjoule. So the correct answer here is option D.